Imagine you are an Ice Age hunter. You need strong muscles to climb, throw, fight, and carry meat back to camp. Testosterone helps maintain much of that physical machinery. But there is a problem. Inside your intestines, worms may be stealing nutrients. Other parasites may be feeding on your blood or forcing your immune system to fight an invisible war. Now your body faces a choice. It can spend energy building muscle and supporting reproduction, or it can spend that energy repairing tissue and surviving infection. It cannot spend the same calorie twice. This means that some of the most important forces controlling an ancient man's testosterone may not have been his age, his bravery, or how many animals he hunted. They may have been creatures he could not even see. Ancient men are often imagined as testosterone giants, muscular hunters with hormone levels far beyond those of men today. But testosterone disappears after death. Bones can reveal injuries, diet, and activity, but they cannot give us a prehistoric hormone test. Scientists instead examine parasites preserved in ancient feces and study hormones in present-day subsistence populations facing high physical demands and pathogen exposure. These communities are not replicas of the past, but their physiology helps investigate a problem industrial life often hides. What happens when food is uncertain and the immune system is rarely off duty? The answer is much stranger than more hardship equals more testosterone. Parasites rarely leave dramatic skeletons behind. Instead, archaeologists search for their toughest structures, microscopic eggs preserved in coprolites, ancient dried feces. At prehistoric sites, researchers have found evidence of roundworms, whipworms, pinworms, tapeworms, and other unwanted passengers. In preserved feces from Bronze and Iron Age salt miners in Hallstatt, Austria, researchers detected soil-transmitted worm eggs in 91% of the samples they examined. And these are only the parasites that survived long enough for us to find them. Delicate organisms often disappear from the archaeological record. What remains is only the fraction of an enormous biological struggle that fossilized. For many men, infection would not have been a rare disaster. It would have been part of the environment, like cold, hunger, and darkness. Testosterone is often treated as a measure of masculinity. Biologically, it behaves more like an investment signal. The brain signals the pituitary gland, which tells the testes to produce testosterone. The hormone helps regulate muscle, reproduction, and other systems. But maintaining a high testosterone body is not free. Muscle requires calories even when it is resting. Reproduction consumes resources. Tissue must be built and maintained. A study of Tsimane forager horticulturalists and Hadza hunter-gatherers found that men with higher testosterone also expended more energy. A 1 standard deviation increase in testosterone was associated with roughly 96 to 240 additional calories used per day. The study was small and observational, so it does not prove testosterone caused the difference, but it reveals the possible size of the trade-off. In a world of supermarkets, an extra 200 calories may sound trivial. In a world where every calorie must be hunted, gathered, carried, or dug from the ground, it can be the difference between surplus and shortage. And parasites push the budget in the opposite direction. A worm does not need to crawl into the brain and turn a testosterone dial. It can influence the system simply by making survival more expensive. Some parasites consume nutrients or cause blood loss. Immunity demands protein and energy. Inflammation can temporarily reduce reproductive hormone production, while severe infections may disrupt organs in the hormone pathway. This may look like weakness, but it can function as emergency budgeting. During illness, maximum muscle and reproductive effort may be less urgent than producing immune cells and repairing damage. Research among older Tsimane men found that testosterone was associated with reduced responses in some parts of the immune system, but not all of them. Higher testosterone was linked to a weaker cytokine response after one type of immune stimulation, while another type showed no significant association. So the familiar claim that testosterone simply shuts down immunity is too crude. The relationship is selective and two-way. Testosterone modifies immune activity. Infection and injury can push testosterone down. The body is not choosing between an immune system that is on and one that is off. It is continually deciding how much to invest in each part. One of the clearest windows into this trade-off comes from the Tsimane of lowland Bolivia. Studies document intense parasite exposure. In one sample, more than 2/3 of adults showed signs of intestinal parasites. Eosinophils, white blood cells involved in many parasite responses, can be several times higher than United States reference levels. Tsimane men have also shown significantly lower baseline testosterone than age-matched American men. At first, this seems to confirm the simple story: more parasites, less testosterone. But then, researchers asked the men to compete. After a soccer match, testosterone increased about 30% and remained elevated an hour later. In another study, 1 hour of tree chopping produced an average rise of almost 49%. Their testosterone system was not broken, it was responsive. Instead of paying the cost of permanently high levels, the body could release a temporary surge when intense work or competition made it useful. Think of it as a fire that is kept low to conserve fuel, then fed rapidly when the moment demands heat. Energy budgeting is only one route. Some infections are associated with much more direct hormonal disruption. Men infected with the filarial worms La and Mancinella perstans often showed low testosterone or abnormalities in the pituitary hormones controlling the testes. The disruption became more pronounced with heavier La infection. Men with African trypanosomiasis, sleeping sickness, showed increased cortisol and decreased testosterone. The disturbance sometimes persisted after treatment. But parasites do not all push testosterone in the same direction. Studies of Toxoplasma gondii conflict. Some report higher testosterone, others lower levels or reproductive damage, and many cannot determine cause and effect. This is important. Parasites were not one coordinated army with a single strategy. They were thousands of species interacting with different organs, immune pathways, diets, and human genes. The real controller was the struggle between parasite, immune system, and available energy. Now return to the prehistoric hunter. He wakes with parasites in his gut and limited food and storage. His baseline testosterone may not be exceptionally high. Maintaining unnecessary muscle every day would consume energy that could keep his immune system working. Then the hunt begins. He runs, climbs, coordinates, and takes a dangerous animal. A short hormonal surge may support that effort without forcing his body to pay the cost year-round. This produces a very different image of ancient masculinity. The successful man may be the one whose body raises testosterone when useful, lowers it when costly, and keeps enough energy to survive infection. Hormonal flexibility, not hormonal maximum, may have been the real advantage. This is an evolutionary interpretation, not an ancient hormone reading. Living populations cannot give us an Ice Age testosterone level, but they expose a system suited to pressures ancient humans faced. Parasites may even have influenced which bodies survive long enough to reproduce. A man investing heavily in muscle and mating might be formidable in a contest, but vulnerable during chronic infection. A more flexible man might recover better, live longer, and raise more surviving children. Across thousands of generations, that trade-off could shape how human hormone systems respond to danger, competition, illness, fatherhood, and food shortage. Parasites did not need to want anything. Natural selection has no plan. Bodies that balance these costs more effectively were more likely to persist. The parasites evolved too, hiding from immunity, altering inflammation, and exploiting the body's chemistry. Human evolution was never only humans against weather and predators. It was also an arms race taking place beneath the skin. So, did ancient men have more testosterone than men today? We cannot know from fossils, and there was no universal ancient man. Hormones varied with age, food, illness, social life, and environment. But the evidence destroys the simplest myth. Extreme conditions did not automatically produce permanently extreme testosterone. In environments filled with parasites, constantly high levels could be an unaffordable luxury. The more useful system was adjustable, low enough to protect the body's survival budget, but ready to rise when work, competition, or danger demanded it. Ancient men were not shaped only by the mammoths they chased or the predators they could see. They were also shaped by microscopic enemies consuming their food, stirring their immune systems, and quietly changing what their bodies could afford. The strongest hunter in prehistory may not have been the man with the most testosterone. It may have been the man whose body knew exactly when to spend it.